Imagine standing beneath a building so tall that its peak disappears into the clouds. Rising 828 meters into the sky, the Burj Khalifa is the tallest building ever constructed by humans. But what makes this achievement even more incredible is that it wasn't built on solid rock. It was built on desert sand. How did engineers make that possible? Today, we're uncovering the remarkable engineering behind one of the greatest construction projects in history. When Dubai announced plans to build the world's tallest skyscraper, many people questioned whether such a massive structure could survive in the harsh desert environment. The site offered breathtaking views, but beneath the surface was a major challenge. Unlike many cities where skyscrapers are anchored into strong bedrock, Dubai's ground consists mainly of layers of sand and weak rock. Engineers needed to create a foundation capable of supporting a building weighing hundreds of thousands of tons. To solve this problem, they drilled 192 reinforced concrete piles approximately 50 meters into the ground. These giant piles acted like enormous roots, transferring the building's weight deep into stronger soil layers. Above the piles, engineers constructed a massive reinforced concrete raft nearly 4 meters thick, spreading the tower's enormous weight evenly across the ground. Special protective measures were also used to reduce the effects of groundwater and corrosion, helping ensure the foundation would remain durable for decades. With the foundation complete, another extraordinary challenge began. The higher the building rose, the harder it became to deliver concrete to the upper floors. Ordinary concrete would lose its quality before reaching such extreme heights. Engineers developed a specially designed high-strength concrete that could remain workable while traveling through long vertical pipelines. Using powerful high-pressure pumps, crews pushed concrete to record-breaking heights, setting new benchmarks in construction technology. Because Dubai's daytime temperatures often exceeded safe limits for large concrete pours, much of this work was carried out during the cooler hours of the night. Every successful pour represented another engineering milestone. As the tower climbed higher, wind became one of the greatest threats to the project. At extreme heights, strong winds can cause buildings to sway, creating discomfort for occupants and placing enormous stress on the structure. Rather than fighting the wind with brute strength alone, engineers chose a smarter solution. The Burj Khalifa was designed with a Y-shaped floor plan and a series of setbacks that become progressively smaller toward the top. This constantly changing shape confuses the wind, preventing powerful swirling air currents from forming around the tower. The result is a building that remains remarkably stable, despite the intense winds found hundreds of meters above the ground. Construction officially began in 2004. Thousands of workers from around the world worked day and night to transform the ambitious vision into reality. Advanced climbing formwork systems allowed the reinforced concrete core to rise efficiently floor by floor. Massive tower cranes lifted steel, glass, and construction materials hundreds of meters into the air. Every stage required incredible coordination, precision, and planning. As the tower approached its final height, the engineering challenges became even greater. Transporting workers and materials to the upper floors took longer each day. High winds occasionally delayed crane operations. Engineers continuously monitored every part of the structure, using advanced surveying equipment to ensure that each floor remained perfectly aligned. Even tiny measurement errors could have become serious problems over such an extraordinary height. After years of relentless effort, the Burj Khalifa reached its full height in 2009 and officially opened in 2010. Standing 828 meters tall, with more than 160 occupied floors, it became far more than just the world's tallest building. It demonstrated what modern engineering, advanced materials, and international collaboration could achieve. The Burj Khalifa introduced innovations in foundation engineering, high-strength concrete technology, vertical pumping systems, and wind-resistant structural design. Many of the techniques developed during its construction continue to influence super-tall skyscrapers around the world today. Looking at the completed tower, it's easy to admire its beauty, but beneath its elegant glass exterior lies one of the most sophisticated engineering systems ever created. Every pile beneath the ground, every concrete pour, every steel connection, and every design decision played a vital role in making this incredible structure possible. The Burj Khalifa is more than a skyscraper. It is a symbol of human ambition, innovation, and determination. Built on desert sand and engineered to withstand powerful winds, it continues to inspire engineers across the globe. Subscribe to Build Beyond for more incredible engineering stories.